DevOps admin David from Trivial Solutions IO here. And today's topic I will cover is like my personal very pragmatic style about Linux performance, and a lot of people are like very excited. They might dedicate more time than they need to for this topic. Some people might not actually even need to get into those nitty-gritty details. So I'll try to cover like entire range from where you don't need to do anything at all to where you really need to dig in deep, right? So let's start. So the first question, if you're wondering about Linux performance, do you need to do anything about it? Because sometimes there are a lot of people like, you know, they might have 100 users or something, or they're just starting out, or they're just in such a niche that they will never need to really do anything. I'm not saying like that's a bad business or anything. There are a lot of successful people that, you know, run server infrastructure, but they run very little, only as much as they need, and it's not much, you know, not much servers, not many servers, not much CPU usage and everything. It's just that their business model, and they are very successful at that, and make a lot of money, and they might even not need to do anything with it, right? So, for instance, like, you know, my blog that I created, Trivial Solutions IO. It's a WordPress blog, right? And I could really start, you know, hammering deep. Oh yeah, man, I need so much performance. I'm running all the flame graphs like 2D profiles. We'll talk about this later and everything, right? But I know that I will probably not have many users at such sufficient scale that I will need to do anything. Frankly, I didn't do anything regarding performance. I just run Docker containers inside. I don't even use clustering solution like Nomad or anything. I don't have high availability. It's just one server, and that's it. And I don't do anything else. And I know I will live a long time, because I think in this case, my time is more valuable than, you know, getting every drop of a last cycle of a CPU there. Right? So if you're in such place, you know, good for you. And how to know that you're in such place, right? Usually your CPUs are idle, right? Your servers are not working, so you don't have many disks IOPS, you don't have high CPU usage, CPU IO pressures. Your server is idle, and then you don't need to do anything. And if you're here, you can stop watching this video, because the rest of this is irrelevant for you. You're welcome. I just saved a lot of time for you. No problem. So yeah, but if you actually need, if your CPUs are busy, right? If you're actively doing a lot of requests, then the very first thing, before you optimize anything, before you try to do this or that or anything, you must have numbers. If you don't have numbers, well, you can have like rule of thumbs, try this and that, right? Yeah, if you're experienced, it may work, but you know, I don't like doing optimizations in the blind. So I want to have numbers. I want to have like Prometheus with node exporters on every node. I want to see metrics of every node. I want to see application metrics. Why to do that is because I met some people that, you know, this type of person that doesn't have any numbers, and oh yeah, I'm putting these compiler flags, oh yeah, this will be blazing fast, I'm putting this, that, and there's just no way to compare. How do you know if anything you did actually any effect if you don't have numbers, right? So you must have numbers, you must have metrics, and you must have a way to compare before and after performance. Like, you know, fat people who lose a lot of weight, right? So they have before and after pictures. If you don't have before and after pictures of your metrics, and you're doing like optimization stuff like that, I think you're wasting your time. You're wasting everyone's time. I don't say this directly, like sternly like that to the clients, but since this is a YouTube video, right? I'll say to you bluntly, if you don't have numbers and you're performing like changes, like kernel changes, compiler flag changes, whatever, you're wasting everyone's time. You have no way to compare what you did had any positive effect. Because, I noticed from practice that a lot of times you read like, some kernel option, Linux kernel option in documentation, and it sounds, this sounds like if you change that, the things will improve. And then you change it, you should look at the numbers and it's the same, and nothing changed. But if you were this like, guru, just going by the rule of thumbs, by feeling, you'd say, oh yeah, I changed those totally, all those changes were needed, right? So like from the surface, it might look like you actually did something better, but it could have been like you did 10 things at a time, like 3 actually worked, 3 contributed to the performance increase, and 7 you just did willy-nilly, and you don't even have an idea if they worked or not. So that brings me to the next point. If you do a change, very important, and I think it could be the main point of this video, just one phrase. If you change something, change only one thing at a time. If you change more than one thing at a time, like a kernel setting, giving more memory or whatever, if you changed more than one thing at a time and things improved, how do you know which change caused the improving? Then you need to, again, try to set back. And there's a lot of, permutation. And this is like I read a racing book. I do a little sim racing as a hobby. And it's the same thing, like change says in that book, when you go to drive, you change only one thing at a time in a car. Otherwise, how do you know which change improved things or made worse, right? So change only one thing at a time and compare before and afters. Do not be like, I'm repeating again this, but I think it's extremely important. Do not be this like wizard guru that, I'm changing all these knobs, right, everything, and I have no idea which things caused what, right, and I have no way to compare. Don't be that guy. Change one thing at a time and compare before and after, right? So now that we have this out of the way, what we need to do to actually make performance changes in our infrastructure, let's go about some lazy methods I do that, I found in practice that work quite well by using this methodology. I just changed one thing and it improved things certainly, right? So let's start. So bare metals, right? So if you're running in a cloud, you can also get bare metals, but you might not even need to do that, right? You might need to do other things. This might be very little overhead comparatively if you're running in a cloud. But I'll just say this one thing, that everyone runs bare metals. It's just that when you run in a cloud, you run inside someone else's bare metal inside a virtual machine, right? So you definitely have some overhead inside a bare metal. Not inside bare metal, but inside a virtual machine, your cloud instance. It may be negligible, you may not care about it, but I'm just saying, if you want to go like absolutely zero overhead, because how I do like with servers, I just try to remove all the overhead, and then, you get maximum beef out of server, and then you can forget about it because, it does, you did everything you could to have the least possible overhead, right? So not everyone might be able to run bare metals, but I'm just saying, if you're running bare metals, you're at an advantage. You have the highest possibility to optimize to such a way that you'll just win against everything, right? So another lazy way is there's this called the TuneD service. So what this does is, so that I could do lazy performance optimizations guide. So there's this TuneD service that has a lot of profiles already built in. right? And depending on business case, what do you do? Say, if you do like high frequency trading, network latency is everything. Tunity has network latency profile so that you can just say, TuneD, I want this profile so that my network latency is optimized. And TuneD service is a standard package on Linux distributions. Will dial all the knobs for you that, a lot of engineers spend hundreds of hours on optimizing, that they know their stuff and they optimized all these profiles, right? And then they'll change these settings and you can look up which settings are these so that this profile, would be turned on. Or maybe you're doing like ETL computations, like data intensive, like, Apache Spark jobs, right? In HDFS. You might want to do like a compute throughput performance, right? So this is I really like this way because I don't need to be like a super expert on Linux kernel options. I just like spending time most on building software, right, and delivering stuff. Yeah, so I can just set this profile and what I want, and as if export configures my Linux kernel settings, so the service will do for you, depending on the profile that you want. You can optimize for virtual machine hosts if you run virtual machines. So yeah, so I think that's a very good way very lazy way to do very little and just setting TuneD profile for your performance needs. And now we'll talk disk IOPS. And in disk IOPS, my lazy way, and I showed this in ZFS video, that I just use RAID 1.0 typically. Because, if the application doesn't need that much performance, and use RAID 1.0, RAID 1.0, then, it doesn't need it and it will not use it. But as I run a lot of applications on one server, some applications might need it. You might run a database, you might run a queue, you might run blockchain nodes. Those are I/O intensive, right? So on IOPS, you'll get most IOPS with RAID 1.0. And if I said RAID 1.0, I know I can run like the most intensive IOPS workloads out there. And but this is not, as I read, the biggest, the greatest setup for most throughput. Like if sequential reads, if streaming is more your thing, you might need to do something like RAID Z2 on ZFS. Then you might get more sequential reads, right? But it will not be bad with RAID 1.0, but these cases are, I think, a lot more rare. So if you just go for most IOPS, RAID 1.0, you're safe in most cases. And even if you have like streaming needs, this could also serve this. It might not be the most efficient, but you can do that still, right? And this has the most IOPS, and I just imagine if you do that, you can run pretty much any service you want on your servers, right? So this is my choice for a disk setup. And another thing that worked, that I actually measured it, does this work, right? And it really helps, is core pinning. So what is core pinning? All right, so say your server has like 4 CPUs. That would be a very old server, right? And let's visualize it like that. 4 cores, right? And you're running some application A. And if you don't do anything by default, what Linux will do is like schedule to run on 1 core, right? Then some other time it will run on this core, some other time it on this core, right? Some other time it on this core, and you multiply it by threads, and your threads are traveling between the cores. So, but what happens if you do a core pinning, right? So in Nomad, you can, for instance, run a job and say, I want to reserve, like say, 4 cores for this job, and your job, when it creates threads, it will only run on those cores. So what happens if you run application A, but you say, I need 2 cores, right? So it will run only on, say, these 2 cores. And it will never swap from core to core. And why this is significant
because CPUs have this thing, cache lines, right? So cache lines, they cache RAM memory, right? So if your application thread travels across cores, then there's a lot of cache that just gets invalidated, wasted, as opposed to if you just ran it on one single core the entire time, the cache is always hot for that server, and probably memory accesses will be a lot faster. And there's also some overhead with context switching, right? So you avoid both of these things if you pin to certain cores, your services. But like as with most things, I don't do these unless I have to. Unless I see, okay, numbers, if numbers tell me, or the requirements, SLA changes, right? And I need to squeeze every single drop of performance, then I might use this trick that I pin application to the cores, right? So these are a few lazy ways I do to achieve application performance. And another thing, but these are related to operating system environment, right? So this is not like directly, if you don't control the code, you might use this to something like Postgres instance. So you're probably not going to recompile Postgres. Neither should you recompile it. I'm not confident that I could make performance improvements quickly on Postgres as opposed to guys that worked on it for decades, right? So I can only tweak operating system in such cases. But if it's application that we own, and we can profile it, or you can profile even operating system. So you do a flame graph profile on either a kernel level or on the certain application level. You can select PID and do that, or you can profile the entire kernel stack, right? You might need to know which syscalls are spending a lot of time. Once I, profile ZFS, why is it? I could have gotten more throughput, right, as it's only serving from RAM, and I found that this one lock is always hitting, So yeah, so you can do flame graphs and then see where in the busy application state or in OS state, once it's busy, where it's spending most time, right? And you can Google about this, Gregg flame graph, right? And okay, so this is my lazy way, right? If we got like here that we need to do these, we're quite deep, right? But there's a completely other world of deep, right? And if it's not enough and you need to dig in even deeper, then I will just recommend you read a book about systems performance by Gregg, the same guy that invented those flame graphs. And I read it. It's like it's huge chest of tools. Like you could even pick a chapter what you're having with. Are you having problem with file system performance, block device performance, network, CPU? You can read by chapters if you want, right? Or you can just read it all. I read it all. It's a huge book, right? And so that's and I would read this book not just for if you have like a performance problems, but I also recommend reading this book because you'll just learn a lot of Linux tools. Well, they're performance related, but you'll learn about a lot of visualizations and whatnot, right? I saw a huge tool chest in here, right? So it's just good for general understanding of how Linux works, right? If you're into that thing. And passionate people should be into that thing, right? So this has been my lazy, pragmatic guide about Linux performance. How do I start, or if I do anything, if I need to do something, I go more and more complex into the possibly complete rabbit holes, right? So that's how I roll with Linux performance. This has been David from Trivial Solutions.io. I'm signing out. Peace.